Okay, so let's try to solve this problem in which we are given with a sample of charcoal which is weighing 6 grams and it is brought into contact with the gas contained in a vessel of 1 liter capacity at 27 degrees Celsius. The pressure of the gas is found to fall from 700 to 400 millimeter of Hg. We have to calculate the volume of the gas at STP, that is absorbed per gram of the absorbent used under the condition of the experiment. It is also given that the density of the charcoal sample is 1.5 grams per ml.
Right. So let's see how we solve this question. Okay. So first we'll use Boyle's law. We know that pressure is inversely proportional to volume at constant temperature, right? So we know that adsorption is taking place, right? So I can use P1 V1 is equals to P2 V2 because I know the initial and the final pressures. So and I know the initial volume also, volume of the vessel is 1 liters, right?
Yes.
So the volume of the gas will also be 1 liter.
Okay.
Right. So pressure falls, so the volume will increase. Now I'll find out the final volume P1 V1 by P2. So I'll simply substitute the values 700 into 1000 upon 400 because I know that the pressure is going from 700
to
400 millimeters of Hg.
Yes.
So this volume, the final volume comes out to be 1750 ml.
Okay.
So we see that the volume has increased. Like under these conditions, the volume should have increased.
Because the pressure has decreased.
The pressure has decreased, right. Now, when charcoal is added to the flask, the effective volume of the flask wherein the gas would be present will decrease. Why? Because some amount of gas will get absorbed on the surface of the charcoal.
Okay.
Right? So, actual volume of the flask, we'll calculate. Actual volume of the flask will be what? 1000 minus the volume occupied by charcoal.
Exactly.
And we are given the density of charcoal as and the mass also, right?
Yes.
6 grams, right? So
it becomes
1000 minus 6 upon 1.5. 1.5 gram per cc is the density and 6 grams is the weight.
Yes.
So we get 996 ml. This is the effective volume of the vessel.
Okay.
Okay. Now, this volume of the flask will have gas, but as calculated above, the volume of the gas will be more. So the difference in the volume is the amount of gas which is getting absorbed on charcoal.
Okay.
Right. So we'll calculate that. Volume of gas absorbed will be equal to 1750 minus 996.
Exactly.
Right. This should have been the volume, but this is the volume. That means the difference got absorbed.
Yes.
Right. So this is 754 ml.
So 754 mm of gas was absorbed.
Now I'll find out the amount of volume of gas absorbed per gram of charcoal.
Okay.
So I'll simply divide this by 6.
Yes.
So 754 by 6, which is 125.67, and the units will be ml by gram,
Grams.
milliliter per gram. Right. So I need to find out what do I need to find out in the question? The volume of the gas absorbed at STP.
Okay.
Right.
That's standard conditions.
Yeah. This much amount of gas is absorbed at 27 degrees Celsius.
Okay.
Which is 300 Kelvin.
Yes.
Now what is STP? It is the standard condition of temperature and pressure, which is 273 Kelvin or 0 degrees Celsius and 760 mm of Hg.
Okay.
Right. So for this I can simply use the formula. So yeah.
Okay.
Right. So I can simply use the formula P1 V1 by T1 is equals to P2 V2 by T2, which is simple. It is equals to R, and R is a universal gas constant. So, right, I know that the initial pressure is 400 mm of Hg.
Yes.
Final pressure, no, not the final pressure actually, the pressure at which I want to know the volume of gas absorbed is 760 mm.
Exactly.
It is at STP. Now I know that the T1 should be 300 Kelvin and the required temperature is 273 Kelvin.
Okay.
And I just calculated V1. The volume of the gas absorbed at 300 Kelvin is 125.67 milliliters per gram.
Okay.
So I'll simply substitute all these values in this formula. So V2 I will obtain as 60.19 ml per gram. So this is the volume per gram of charcoal, volume of the gas that will be absorbed at STP.
Okay.
Right.
So by this we end this question. Okay, so let's try to solve this question. In this question, 1 gram of charcoal is taken and its surface area is 3.01 into 10 to the power 2 meter square per gram. It absorbs 100 ml of 0.5 molar acetic acid in a single layer. After adsorption, its molarity becomes 0.49 molar. You have to find the surface area of charcoal covered by 1 molecule of acetic acid.
Right.
So it sounds very interesting.
Yeah, but it's a very simple question really. If you see, I'll tell you why. See, you've been given the area per unit weight, per unit
Yes.
mass, right? You've been given the mass also.
Okay.
So you can find the total surface area of charcoal,
Exactly.
which will be 3.01 into 100 into 1 meter square, right?
Yes.
So 301 meter square.
Yes.
Right. Now, you know the total area, right? Let's say this is TSA, total surface area.
Okay.
Okay. You know, what do you need to find out? The
So-
area covered by one molecule, and you know that a monomolecular layer is formed.
Yes.
So we just need to find out the number of acetic acid molecules, right? Because if we know if the entire area is covered by a
Okay.
unimolecular layer, then
We
the
can just divide the total surface area by the number of
exactly
molecules.
the surface area covered by one molecule into the number of molecules will give us the total surface area.
Exactly.
Right. So we so the question boils down to finding number of CH3COOH molecules. Let's see how we do that. I've been given 100 ml of 0.5 molar CH3COOH solution,
Yes.
and the final molarity becomes 0.49 molar. So how much is the amount absorbed? 0.5 minus 0.49, which is 0.01 molar,
Yes.
right? So yeah, I'll just scroll down, and so I know that in 1000 ml 0.01 mole of acetic acid is present. That is the definition of molarity, right?
Exactly.
Now in 100 ml, here I have 100 ml solution. In 100 ml it will be
0.001 mole.
0.001 mole, right? So now this is the number of moles. Now I can find out the number of molecules. Simply multiply by the Avogadro's number. Na into 0.001 molecules. This is 6.023 into 10 raised to the power 23 into 0.001 molecules.
Okay.
So this will be 6.023 into 10 raised to the power 20
Yes.
molecules. Now I have the number of molecules.
So this we have to divide this number by total surface area to find our answer.
Right. Yeah. So surface area of one molecule,
Which is covered by one molecule.
surface area which is covered by one molecule, which we need to find out in the question, is total surface area of charcoal upon the number of molecules of acetic acid.
Exactly.
Right. So I have both the values. I'm simply going to divide them. 3.01 into 10 raised to the power 2 upon 6.023 into 10 raised to the power 20, which is, if we solve, it will come out to be 5 into 10 raised to the power minus 9 meter square per molecule. So as we saw, it was a fairly easy question.
And an interesting one also. Okay.
Right.
Okay, let's try to solve this question in which you are given that a solution of palmitic acid in benzene contains 4.25 gram of acid per liter. When the solution is dropped out of water surface, the benzene evaporates and the palmitic acids form a unimolecular layer on that surface. If we wish to cover an area of 500 centimeter cube with the monolayer, we have to find the volume of solution to be used for doing this.
Right. So it's a very easy question again. It just looks very lengthy and complicated. So I'll start.
And
the
don't get
solution.
scared by just seeing the size of the
Size
question.
of the question, right? So yeah, concentration of palmitic acid is given to me as 4.24 gram per decimeter cube.
Yes.
Right? So mass of palmitic acid in this solution will be given by concentration into volume,
Exactly.
moles basically. Yeah, but the concentration is in gram per decimeter cube. So yeah, concentration into volume. Now to calculate the overall mass, we need to see, basically we know the area, total area, we know the area covered by one molecule. So we need to find out the number of molecules first,
Yes.
and then we can find out the mass,
Okay.
right? And once we do that, then we can find out the volume of the solution because we know the concentration of the solution.
Right.
So it's very simple. Let's see how we go about it. So to calculate the overall mass, we need mass of all the molecules, for which the number of molecules must be determined first.
Okay.
Right. So I can write that, see, number of molecules upon Avogadro's number, which is the number of moles,
Exactly.
into the
Yes.
mass number. Right. This will give me the mass of palmitic acid.
Exactly.
This should be equal to concentration into volume.
Yes.
Right. Now, I will write this equation in terms of N and V, a
Okay.
general equation, okay, because the rest are constants. So, mass number or molecular weight has been given to us as 256 upon 6.02 into 10 raised to the power 23
Okay.
is equals to, concentration is given to me as 4.24 upon 1000 into V.
Okay.
Okay, because V I am taking in cc, centimeter cube.
Okay.
Here.
That is ml.
Yeah, ml, right, milliliters.
Okay.
So now when I simplify this and solve, I will obtain N as 9.976 into 10 raised to the power 18 into V.
Okay.
Fine. So now, how do we proceed? Now we have the total area to be covered with us, which is 500 centimeters square,
Yes.
and we have the area which is covered by one molecule, which is 1 nanometer square. Nanometer
Okay.
is 10 raised to the power minus 9.
Yes.
Right. Now, so area covered by these molecules, if the number of molecules are these many,
Okay.
then the area covered by them, area covered by these molecules will be what? N into 1 nanometer square.
Exactly. Because 1 nanometer square is the area covered by one molecule.
Now, area covered by palmitic acid molecules, these many. Now, N I can substitute from this equation.
Yes.
So, I will obtain 976 into 10 raised to the power 18 into V into
1 nanometer square, that we can write as. Okay.
right. So,
Okay, the area
in the
covered.
question, the area covered by one molecule is given as 0.21 nanometer square. I'm really sorry for this mistake.
No problem.
Yeah, this is why you should read the question carefully. This is, these kind of mistakes students make very often. They read the question, wrong, and then that leads to erroneous answers.
Yes.
So, my bad, my mistake. I'm really sorry. So, yeah, this will be 0.21 into 10 raised to the power minus 7 square. I'll make the unit same, uniform. I'll convert this in centimeter
Nanometer
square.
square into centimeter
Square,
square.
right.
Okay.
So this I will get 2.095 into 10 raised to the power 4 into V centimeter square. So this is what the area covered by N palmitic acid molecules, right?
Yes.
Yeah. Now I know that my total area is 500 centimeter square. See, that is why I converted the units into centimeter square.
Okay.
Should be very careful with the units, right? So
Students often make mistakes. Why not? By just neglecting the units.
Neglecting the units, or if you need to divide two values, you need to see that, make sure that the units are same. Otherwise,
Okay.
you will get wrong results. So my total area is this. This is the area covered by n molecules. So I can equate both of these.
Yes.
So 2.095 into 10 raised to the power 4 into V is equals to 500. From this I will obtain the volume as 0.024 ml.
Okay. So by this we end this question.
Yeah.
Okay, so let's solve this question in which we are given with this graph between log x by m and log p. It is also given that the pressure is 0.2 atm. We have to find the value of x by m.
Right. So it's a very direct question, right? It's very, very easy. We've been given the graph. We know
Yes.
from Friedrich isotherm that the equation of this graph is this. Log of x by m is equals to log of k plus 1 by n log of p.
Exactly.
So this is a equation
Of the form y equal to mx plus c.
y is equals to mx plus c, the equation of a straight line,
Exactly.
in which m is the slope and c is the intercept.
Okay.
Right, so if I compare this equation, I will get that m, the slope here is 1 by n, which is in this case tan 45, which is 1,
Exactly.
and log of k, which is the intercept, is given as 0.301. So from, we obviously know the values of log of 2 and log of 3, and we know that log of 2 is 0.301, so k is equals to 2.
And if you don't know them, you should remember them
Yeah, you should remember the values of log of 2 and 3 at least.
because they are extremely important.
They're extremely important. So now I have k and I have m. So I have this entire equation determined,
Yes.
right? So log of x by m is equals to log of 2 plus log of p.
Exactly.
Now this equation can also be written in this form, right? X by m is equals to kp raised to the power 1 by n.
Yes.
So I need to find the value of x by m at pressure is equals to 2. So x by m is equals to k I found out as 2, pressure is given as 2, and
And
n
is equal
is
to
1. So x by m is equals to, okay, pressure is given as 0.2.
Oh.
I'm sorry. Yeah. So x by m comes out to be 0.4, and it will be unitless because x is the mass of the adsorbent and m is the mass of the adsorbent, and both are masses, therefore it's dimensionless.
Because the dimensions cancel each other.
Right.
Okay. So by this we end this question. Okay. So let's solve this question. The mass x of a solute absorbed per gram of solid absorbent is given by Friedrich isotherm, which is x is equal to k c to the power n, where k is equal to 0.16 and n is equal to 0.431. We have to calculate the amount of acetic acid that 1 kg charcoal would absorb when a 0.837 molar acetic acid in an 0.83 molar acetic acid solution.
Right. So in this question we'll see the direct application of the formula for Friedrich isotherm, which is given to us in the question, in fact. So x is equals to kc raised to the power n, where x is the mass of the solute adsorbed per gram of a solid, right?
Okay.
So k is given to me as 0.16, concentration of the solution is given to me at 0.837, and n is 0.431.
Right.
So solving this, I get 0.1482 gram
Okay.
of acetic acid per gram of charcoal.
Exactly.
See here, whether you take kg by kg or gram per gram doesn't matter, because
Well, it's unitless.
yeah, it's unitless. So yeah, here x is the amount adsorbed per unit weight mass of adsorbent, right?
Exactly.
This is important. Okay, so I get, now I can write this, I can also write this as as in if I want to write it in the units gram per kg charcoal, then I will get 148.2 gram acetic acid per kg charcoal.
Per 1 kg charcoal.
Simple unitary method. Right?
Exactly.
Yeah. So now I know the molecular weight of acetic acid is 60
Yes.
grams, right, gram per mole. So now I can calculate the number of moles of acetic acid
Yes.
per kg of charcoal, right,
Okay.
which will be 148.2
By 60.
by 60 gram per mole. So I will get 2.47 mole. This will be per kg charcoal.
Okay.
These are moles of
Acetic
acetic
acid.
acid. So I found the answer in terms of mole per kg also and kg per gram per kg also.
Okay.
Right, since it is not mentioned, mostly in the questions it will be mentioned. What do they mean about when they say the amount of acetic acid?
Okay.
But yeah, so that was question number 7.
Okay. And it was an easy question. We just applied the equation which was given to us.
Right.